Today we are moving on from the last video which fitted a t-distribution to shared data. We are using a t-fit in this video to compare the normal distribution probabilities of the trade with the fitted t-distribution probabilities of the trade. We will discuss other important points regarding option trading.
Okay, today I'm estimating the degrees of freedom of a t-distribution. Now traditionally at college or university or wherever you learn in statistics with a t-distribution, it's the count of the data minus 1 is the degrees of freedom. We're taking a different approach because it's not a normal distribution like a t-distribution that's Gaussian, such as with 20 or 30 points of data. Even though there's hundreds of points of data, when you fit the distribution, it's highly elliptokurtic and highly kurtotic, which means it's spread wide, it's skewed, and it's the peak is very much above what a normal distribution's normal peak is. So it's not distributed normally. So the easiest way to use a non-normal distributed distribution for share market analysis is to estimate a t-distribution degrees of freedom and approach it from there. It's a quick and dirty method, a heuristic. I won't go into that here, but it's effective because there's not a high lot of precision. There isn't really much gain by estimating a Levy or it's another distribution, a Cauchy distribution. They may be technically more accurate, but you'll be spending lots more time for not much gain in pragmatic use or what you can use it for. Because a lot of those distributions are pretty well, they're not intractable, but they're much harder to model and use. And the basis of this idea, before I run it, I'll just go down. Oops, we've gone up. Okay. In order to illustrate why we want to fit a t-distribution, apart from my description, which I'm not going into proof, we'll use Chebyshev's inequality, which is a statistical proof which says for any underlying distribution, and if we don't know the shape of the distribution, we can get an estimate. If you use one standard deviation, it's just 50%, which is not really any good. In order to get approximately one standard deviation, you have to use two standard deviations squared, one over that, one minus that. We'll give you Chebyshev's, and we'll run it. And as you can see, Chebyshev, the result from Chebyshev's two standard deviation gives you a distribution spread of approximately 0.75, as opposed to two standard deviations on a normal curve gives you a spread of 0.95. So yeah, if you're unsure whether it's normally distributed and you're relying on 0.95, it's very dangerous and it's wrong. So for my modelling in options trading, which I'll go into later, I estimate the degrees of freedom there, which I'll go through, and we'll see what the degrees of freedom are later. I estimate the degrees of freedom there, which I'll go through, and we'll see what the degrees of freedom are. And I've got a little model where I can show you estimating my probability chances. Okay, so data's a bit untidy because I've been mucking around with it. I tried to get rid of these NaNs, not applicable numbers, but I didn't manage to do it, but it still runs. The library is a tidyquant, which is a wrapper around QuantMod to make it compatible as a data table for dplyr and tidyverse library. Anyway, I'll run it. And we use Fit Distribution Plus, which actually is a superset of the fit distribution which comes in mass, which fits the t distribution. We print the fit. You can see over here the median, mean is there on daily returns. Point is 6 in points 0.0069, 0.007, 0.0007, and the variance, or so the standard deviation is 0.01, 0.01, 0.5, rounded off, and the degrees of freedom is 3.25. Now I'll put that into, that's the model I abandoned. We put that into a user-defined function of log likelihood to estimate a fit for the chart in ggplot. With, I rounded it off to 3.25. I know, yeah I did, yeah. So I'll run this function for the chart, and it converges. Despite the NaNs, it converges. That's our new mean. That's our new sigma. And a convergence. Now we'll generate the chart. There it is there. And with library ggplot, we'll fit the chart. Now there is the, it's quite complex fitting it. It's down here. Degrees of freedom up there is parameter 1, mu is parameter 2, sigma is fit parameter 3, and PDF is the density of the t distribution equals x minus mu over sigma, degrees of freedom over sigma, and degrees of freedom t equals data frame x equals x, PDF equals PDF. It's a PDF, not a CDF. Oh, why have we got a PDF? So it's a double-sided chart, yeah. And we have ggplot. Okay, there's the data there. We'll run it. You could use CDF. It's the cumulative distributions between 0 and 1. The PDF gives a distribution of both tails, not from one-sided. And that's the resulting chart. Goes from minus 10 to positive 10. You can see it's quite spread out. It's very leptokurtic, well above 30, which is the normal cutoff. It's about, I assume that's 5, a bit over, probably about 15 above 30, so it's about 45. And it's spread out from 0.5 to 0.5 most of the data, and the tails go out to 0.01 and beyond, minus 10%. So yeah. Now how does that help? Well, if I go up to here to my my app, Okay, I've run my shiny code here, and I've got my T distribution probability function. Now, that's my strike price, 174. That's the share price at the moment before trade opens in about half an hour, in about 20 minutes in fact. It's 171.4. The implied volatility is 0.233. The number of days left in this particular option is 17 days, and the degrees of freedom of the T rounded off is 3. It only takes integers. At least in my shiny app, it actually does take rounded numbers, but not in this app. Now, if we calculate, we get the chance of the put at 174 being below, of the stock being above the put. The chance of the put being in the money is 0.6079, but as I'm sold short, it's in the money now. It's below the strike because it's a put, it's reverse. I don't want it to be in the money. I want it to be out of the money. And the out of the money probability is 0.39, hence that is why I'm trading it. Take what profit I've got on it. Got 113 hanging there. I'm trading them both out, as you can see there. Slim profit still left, so I don't want it to rise above 445, but it's getting there. Okay, so I'm trading it out. Take a profit. It's complicated. It's actually set up for a call. If a call is in the money, this will be greater than 0.5. If a put is in the money, this will be greater than 0.5. So the put's in the money, but as I'm sold short, I don't want to be in the money, I want to be out of the money. And the out of the money is losing. It's only 0.39% chance of it being out of the money. That's why I'm getting rid of it. Okay, now using a T distribution will give a far more accurate reflection of the true probability than if you use a normal probability distribution. I can tell you 99.9% of people use a normal probability distribution. And to show you how wrong it is, Tasty Trade's probability distribution gives it a 59% chance of it being in the money. Sold short, that is. There's not a chance in hell of it being 59% chance of being in the money. Not with 17 days to go, 14 days to go. It's already 3 points under. It's possible, but it's risky. Anyway, they use a normal probability distribution like everyone else. I don't trust it. It's very few shares are normally distributed. It's a fact. Okay.